Hi, Elsbrun. This goes along with the worksheet I gave you, which says 3.1a at the very top. So we're going to try and figure out the story in the order we put the story um, described below. So I have a couple of things. My pictures are a bad representation of the pictures that are um, actually available. So it says Sylvia has a small pool full of water that needs to be emptied and cleaned, then refilled a pool for a pool party. During the process of getting the pool ready, Sylvia did all of the following activities, each during a different time interval. Okay, so there's the opportunity that she used one bucket, or her and two of her friends used a total of three buckets, or they realized they could just drain the pool, put in a hose in it. We could fill the hose up, but before we fill it, we have to clean it. So if you think about in order we did stuff, this might be the very first event. And then she has friends that come over to do with the three buckets. And then they might have realized we have a better thing to do where we could just empty the pool, with the hose or the drain at the bottom. And then we'd have to clean the pool, refill the pool, and then take a break. Okay, so what do you think about that? So the first thing was her probably scooping scooping water out of the pool. She does it one bucket at a time. So one bucket empty, one bucket empty. And then she has friends that show up and they're like, "Oh, okay, there's three of us that have buckets." So now you start going three buckets at a time, three buckets at a time. And then someone realizes, "Oh, why don't we just drain the pool with emptying it from the bottom with a hose?" And then we have to clean the pool, and then we're going to fill the hose back up with the thing. So I'd say first thing would take place is Sylvia by herself. And then this could be Sylvia and two friends. And then someone was smart and said, okay, why don't we just drain like that? And then they all clean the pool together, fill the hose back, fill the pool back up with the hose. So fill it back up, and then took a break. So if you flip the page over, we want to kind of sketch what this might possibly look like. So I'm just going to use myself. You have a much nicer grid. So, so we're going to say that the pool was full here, maybe. And down here, this would be where the pool's empty. So let's think about what's taking place. So Sylvia starts taking one bucket at a time out. And then she has some friends come over and they start taking three buckets at a time out. And then somebody said, why don't we just use the hose and empty the rest of the pool? Something had to take place, and then start filling the pool back up with a hose. So we could label this. So this is one bucket at a time. And then this was at three buckets. And then this would have been where we would have had the drain the pool with the hose, clean it, and then fill with a hose. And I guess you could go from there. You can say, at this point, take a break. The pool's ready. So they want us to know, does this graph that we've drawn, does it represent a function? So a couple things that are taking place as I progress through this event, this is what's taking place with our graph. So is this a function or not? And I'd say yes, it is a function at this point, and we will see later in this lesson what makes it a function. Okay, a function. A function. So you have points x and y. Agree? For each x, only listed once. For each x only listed once. So if I had like 1, 2, 2, 4, 7, 8, 10, 7, this would be a function because the x value did not repeat. Okay, so let's think about that. So let's now flip over to 3.1b. 3.1b. So a function. We have function, we have x-intercept, we have y-intercept, we have the maximum, we have the minimum, we have the rate of change, where it's increasing, where it's decreasing, where it's 0, domain. If you flip over that page, you have range, you have continuous, which we've talked about a lot, discrete, which we've talked about a lot, and discontinuous. All right, let's go through some of these definitions. So this is on 3.1b. Definition of a function. Graph or points where x does not repeat. Okay, so if you made a picture, any of these could be a function, okay, because the x value doesn't repeat. The x-intercept crosses x-axis. So if I had a graph drawn, an x-intercept, as an example, would be those 2 points there. The y-intercept crosses y-axis. So an example of that would be, let's say I have a graph that looks like this. That's the y-intercept. Okay, a maximum is the highest point or greatest value. Okay. So on a graph, let's say I had a graph that looks like this. This would have a maximum point right there. If I wanted to have the minimum, that is the lowest point. And with our particular graph, this would be the min. Okay. Now, with the arrows at the ends, certain things are taking place, but right now we're talking about local mins and local maxes. Okay. Rate of change is the change in y over the change in x, which is listed. This is the slope, which goes along with this. Increasing is where the slope is positive, so going up. Decreasing is where the slope is negative, so going down. Where it's 0 is where m equals 0, so this is the constant rate. From the pool problem, it's where we were cleaning the pool at the bottom. So if we go back to that, we were cleaning the pool, constant rate, or when we were on our break, okay, that's where the slope would have been 0. Okay, we're also going to put that this is the horizontal line. The domain, the set of x values, the range, the set of y values. Continuous, graph continues. No dots. Discrete, that's dots. Okay. And then discontinuous would be not a continuous curve or graph. Okay. So your homework for tonight, if you would, take a look at that very back side, and you're trying to define if it is a function or not. So you're going to circle either yes or no. If you circle no, so yes or no. If you circle no, why? What was your thinking that took place? Just kind of squeeze it in there. So let's do, if you do 1 through 9 on the back side of that packet. We'll go over 1 through 9 on Tuesday, okay? Have a nice day, everybody.